All right, let's do some L'Hopital, where derivatives meet limits. It's really cool. So L'Hopital is how you say that. And it is L'Hopital's rule, which is really cool. So we're going to write out the full derivative, pardon me, doggone it. We're going to write out the full definition, is the D word I was trying to use there. We're going to write out the full definition because all the different pieces and parts that go with it, I want to make sure you get. All right? So here's the full definition. L'Hopital's rule. Okay, suppose that F here and G are differentiable on an open interval I containing A, so we've got lots of variables we're looking at here. That's a G, containing A with G prime of X not equal to 0 on that same interval I when X does not equal A. All right? Now, if the limit as X approaches A, maybe of F of X is equal, now I'm going to take it down here to this next line, sorry, because this is going to be a little bit longer. So if, here we are, the limit as X approaches A of F of X is equal to the limit as X approaches A of G of X, which equals 0, then the limit as X approaches A of F of X over G of X is equal to the limit as X approaches A of F prime of X over G prime of X. Provided, now I'm going to go through it all, right? So don't worry, we'll come back and talk about this whole thing, all right? Provided the limit on the right, on the right exists or is positive or negative infinity. The rule also applies if X approaches A is replaced with X approaching positive or negative infinity, X approaches A from the right, or X approaches A from the left. All right? Okay, so if you need to at this time, pause to get this definition written down, and then we're going to move forward. I'm just going to move right into talking about it. Here's the deal. Suppose I have two functions, all right? And they are differentiable on this open interval I containing this value A with G prime of X not equal to 0 where X cannot equal A. If this A that we are talking about here, right? I'm taking the limit as I approach A, and then I have both F of X and G of X equal to 0. Here's another little tidbit for you. They can also equal, and here's another, they just write it as a separate definition, and we're not going to because it means the same thing. If your limit is equal to 0 or positive or negative infinity, then my limit as F of X divided by G of X, which is why it can't equal 0, right? Because you can't have that in the denominator over here either. I'm going to take the derivative of the top and derivative of the bottom. Provided the limit exists, any of that. So I can have any kind of limit. That's what this means down here. X approaches A, X approaches positive or negative infinity, to the left, to the right, nobody cares. Here's the key. Here's the key to L'Hopital. We're going to write it out. This is what you're actually doing with L'Hopital. If you have a rational expression, fraction, it has to be a fraction, okay? When you take the limit and get It's called an indeterminate form. Of either 0 over 0 or positive or negative infinity over positive or negative infinity, then use L'Hopital. We are going to take the derivative of the top independent of the bottom. Then take the limit again. That's the layman's version of L'Hopital. So here, let's hit some key points, these highlights here. First of all, in order to do L'Hopital, it has to be rational. If it's not rational, it's not L'Hopital. So look at what's happening here. This is a rational expression. It has to be a rational expression in order to use L'Hopital. That's just how that is. So when you take this limit and you get this indeterminate form of where it equals 0 or positive or negative infinity, 0 over 0 or positive or negative infinity over infinity, infinity over infinity of whatever kind, then you use L'Hopital. Here's what it is. You are taking the derivative of the top, and here's the kicker, independent of the bottom. This, ladies and gentlemen, is not the quotient rule. This is the derivative of f prime of x. Boom, that's all that is. This is the derivative of g prime of x. Boom, that's all that is. The f stays on the top and you just take the derivative of simply the numerator. It is independent. This derivative is independent. All right? That's what makes it L'Hopital. There's a big, huge proof as to why this happens. It's in your book and you are welcome to go through and look at it. I would be happy to talk you through it if that's something that you want to talk about. I'm not going to take class time to do that because L'Hopital's rule is what we need to know. All right? So given a rational expression, if I get an indeterminate form of 0 over 0, or if this is infinity over infinity, positive or negative, then I take the derivative of the top divided by the derivative of the bottom. And that's how we roll. That is L'Hopital. And you just take the derivative again. Because the goal is that now this is something I don't have an indeterminate form of, and I can just go forward with. All right? You know we're going to do some examples. That's coming up next.